All right, let's talk about one of the most brilliant tricks your computer pulls off, literally every single second you're using it. It's this incredible illusion called virtual memory. So let's dive right in.
It all starts with this question, right? And it seems to defy all logic. How can you possibly run a 10 gigabyte program when your computer only has 8 gigabytes of physical memory? I mean, how do you fit something huge into a box that's just too small? This isn't some kind of riddle. It's a real, fundamental problem that computer engineers had to crack. And honestly, their solution is pretty much the reason modern computing even works.
Okay, so to really get how they solved this, we first need to appreciate just how big the problem was. And it all comes down to the hard, physical limits of memory. I want you to think of your computer's RAM, its physical memory, like a workbench, right? If you want to work on anything, whether it's a program, a photo, a game, it has to be on that workbench. The problem is, the bench is only so big. It's a finite resource. And back in the day, if your project was bigger than your workbench, well, too bad. You just couldn't do it. Simple as that. It was a huge, huge bottleneck.
So, how on earth do you get around a physical limitation like that? Well, you don't. You cheat. You create an illusion. A really, really clever sleight of hand that your operating system pulls off, and it's called virtual memory.
The absolute key to this whole trick is one word: separation. What virtual memory does is it gives every single program its own massive, imaginary workspace. It's totally separate from the computer's actual physical memory. So as far as your program is concerned, it has this huge, wide-open space all to itself. It has no idea it's living in a much smaller house. Okay, so this is how the magic happens. Look at this. On the left, you've got the program's virtual memory, this gigantic, seamless block of space. Then, in the middle, that's the real limited physical RAM, our workbench. And over on the right, that's your hard drive, or what we call the backing store. Now here's the clever part. The operating system doesn't try to load the whole program at once. No way. It only brings the active pieces, the parts you're using right now, called pages, into physical memory. And the rest, it just sits patiently on the hard drive, waiting until it's needed.
That leads to the next logical question, right? How does the system know which pieces to pull from the hard drive onto that workbench? Well, it uses this really smart strategy called paging on demand.
And the core principle is right here. Bring a page into memory only when it is needed. You know, it's kind of this elegantly lazy approach. It's genius, really. Instead of trying to cram that whole 10 gigabyte program into memory when you launch it, the system basically says, nope, I'm not going to do any work until you absolutely force me to. I'll load a piece only when you ask for it. And this lazy, on-demand system, it's incredibly efficient.
So here's how that lazy swapper works in practice. First, your program asks for a piece of data, a page. The system checks, is that page already in physical memory? If it's not, something called a page fault happens. Now, I know fault sounds bad, like an error, but it's not. It's actually a totally normal, everyday event. It's just a little signal to the operating system that says, hey, could you go find that page on the hard drive and bring it over here so I can get back to work? And that's exactly what it does. Okay, so now we get the how, the mechanics of this illusion. But why? Why go through all this trouble? Well, the answer is pretty simple. The payoff is absolutely enormous.
I mean, first off, the big one we started with. Our 10 gigabyte program can finally run on our 8 gigabyte machine. Problem solved. But it gets better. Because each program is only sipping a small amount of physical memory at any given moment, we can run way more programs at the same time. Think about all the tabs and apps you have open right now. That's virtual memory at work. This means less waiting, faster response times, and a system that's just way more efficient. It keeps the CPU constantly busy doing useful work, which is exactly what you want.
But, like any good magic trick, there's always a bit of behind-the-scenes work. This incredible illusion, it isn't entirely free. There's a cost.
So what's the trade-off? Well, the system has to do a ton of bookkeeping. It has to keep these complex tables just to track where every single page is located. That management, plus handling all those page faults, takes up processing power. It's overhead. And here's the other big thing. This whole system really relies on having a high-speed storage device, like a modern SSD. Remember the old days with slow, spinning hard drives? That constant grinding noise when your computer was slow? That was the sound of the system desperately fetching pages from a slow disk. It could bring everything to a grinding halt.
So there you have it. Virtual memory is this foundational illusion that literally makes modern computing and multitasking possible. It lets our systems punch way above their weight, acting bigger, faster, and more powerful than their physical parts would ever allow. But, as our apps and our data just keep getting bigger and bigger, you have to wonder,
This is a pretty old trick at this point. How long can this incredible illusion keep up? Or will the future demand a completely new way of thinking about memory? It's definitely something to think about.